गुड इवनिंग फ्रेंड्स, स्टडी विद अपाला इंजीनियरिंग एंड जनरल जियोलॉजी परवीन सिंह बुक। तो हम चैप्टर 9 में हार्डनेस पढ़ चुके हैं। अब क्लीवेज, क्लीवेज क्या होता है? मीन्स सेपरेशन प्लेट फॉर्म में हो रहा है, उस पर कैसा स्ट्रक्चर आ रहा है, स्मूथ है, कैसा है क्लीवेज, यानी कि सेपरेशन ऑफ पार्ट। अगर हम मिनरल को तोड़ रहे हैं, कर रहे हैं, तो उसका सरफेस कैसा बन रहा है। कई बार आँख से आपको समझ में नहीं आएगा, जब डिटेल में स्टडी करेंगे तो और क्लियर होगा इन अ प्रैक्टिकल लैब। तो आप लोग लैब भी ज़रूर जाइए। It is defined as the tendency of a crystallized minerals to break along certain definite directions, yielding more or less a smooth plate, a plane surface. In other words, cleavage planes are the planes of easiest fractures and are essentially the indicating of a direction of least cohesion in the atomic constitutions of a mineral. मिनरल्स में हैव द क्लीवेज इन 1, 2 और 3 डायरेक्शन, यानी कि वो एक डायरेक्शन में भी टूट सकता है, 2 डायरेक्शन में और 3 डायरेक्शन। फर्दर द डिग्री ऑफ ईज इन splitting along cleavage direction may vary in the same minerals. As such, cleavage is described both in terms of number of directions in which it is observed on a minerals, and also in terms of degree of perfect splitting. Since cleavage direction are always parallel to certain crystal faces in a minerals, these may be described as such. For instance, cubic cleavage galena and halite, rhombohedrals cleavage calcite, and prismatic cleavage basal cleavage, and octahedrals cleavage. In terms of perfections, the cleavage is described as eminent, perfect, good, distinct, and indistinct in that order. In eminent cleavage, the minerals can be split very easily, yielding extremely smooth surface. Example in mica, perfect cleavage are seen in orthoclase and calcite. Parting. It is a property of minerals by virtue of which it can split easily along certain secondary planes. Although it may be confused at first with the cleavage, but its true natures can be established by a careful study. Parting is actually due to the presence of a secondary twin planes and gliding planes along which the minerals may split easily. These parting surfaces are not necessarily related to the minerals as a spices. That is, they may be present in one specimen and absent in the other specimen of the same minerals. Parting is attributed to the presence of a substance of a different composition along the parting planes, or to the stress that might have operated during or after the formation of the particular crystals. Best examples of partings can be seen in corundum, where cleavage may be absent but partings may be very prominent. Fracture. The appearance of the broken surface of a minerals is a directions other than that of cleavage. Is generally expressed by the terms of fractures. In some cases, fracture become a characteristic property of a mineral. Common type of fractures are even when the broken surface is smooth and flat. Example chart. Uneven when the minerals break with an irregular surface which is full of minerals ridge and depressions. It is a common fractures of many minerals. Example fluoride. Conchoidals, the broken, ये भी हम लोग प्रैक्टिकल में बहुत करते थे, लिखना पड़ता था कि इवन है अनइवन है इन ये few words. The broken surface of the mineral so broadly concentric ridge or concavity with many of may be deep or faint in outlines. In the latter case, the fractures may be termed as a subconchoidals. Example quartz splintery. When the minerals break with a rough woody, fractures resulting in rough projections at the surface. Example kyanite. Heckleys, the broken surface is highly irregular with numerous sharp, fine, pitching, earthy. The surface is smooth, soft and porous. Example chalk. Tenacity, ये क्या है? The behavior of a minerals towards the force that tend to break. bend, cut or crush, it is described as the term tenacity, यानी कि इलास्टिसिटी कहेंगे उसकी. Thus, when a minerals can be cut with a knife, यानी कि हम उसे नाइफ से काट पा रहे हैं कि नहीं काट रहे, it is described as a sectile. It is the if the slice cut out of it can be flattened under a hammer, hammer की ये हथौड़ा जिसे कहते हैं हिंदी में, it is said to be malleable. Most minerals exhibit the property of a brittleness, by virtue of which they change into fine grains or powders when scratched with a knife or when brought under the hammer. The minerals is said to be flexible so when it can be bent, especially in thin sheet. Chlorides are so flexible. Some minerals are not only so flexible but elastic. That is they regain their shapes when the force applied on them is removed. Micas are best examples. The flexible elastic fibers of asbestos can be woven into fireproof fabrics. As such, in terms of tenacity, minerals may be sectile, brittle, flexible, plastic, and elastic. The two last two qualities begin beings of a diagnostics importance. Structure form. Minerals often occurs in characteristic body forms or physical shapes. The physical make-up of a minerals is expressed by the terms structure and is often helpful in identifying a particular mineral. In a reality, structure merely show the habit in which the crystals or crystalline substance making a mineral tend to occur in nature. So following are a few common structure forms habits observed in minerals. Tabular. The minerals occurs in the forms of flattened square, rectangulars, or rhombohedral shapes. In other words, flattening is conspicuous compared to lengthwise elongations. Example: calcite, orthoclase, barite. It's elongated when the minerals is in the forms of a thin or thick elongated column-like crystals. Examples: barley, beryl. Quartz hornblende. It is also commonly referred as a columnar structures. The blade itself, the minerals appears as if composed of thin flat blade-like overlappings or just opposed part. Example: kyanite. ये फिगर आपको बनाने हैं, छोड़ना नहीं है, ये पूरे बहुत इम्पोर्टेंट है. Lamellar. The mineral is made up of a relatively thick and flexible leaf-like sheet. Example: vermiculite. Foliated. The structure is similar to lamellar is in broader sense, but in this case the individual sheets are paper thin, even thinner, and can be easily separated. Example: muscovite mica. Fibrous. When the minerals is composed of fibers, generally separables either quite easily. Examples: asbestos, or with some difficulties. Examples: gypsum. ये radiating capacity. आज टंग बहुत स्लिप हो रही. The mineral is made up of needle-like or fibrous crystals which appears originating from a common point, thereby giving a radiating appearance. Example: iron pyrite. Whence needles are pointed and not necessarily radiating, the structure is called acicular. Granular. The minerals occurs in the forms of a densely packed mass of a small grain-like crystals. Example: chromite. Granular magnetites, globular hematites. आप अगर सारी एजुकेशन कर चुके हैं, कंपटीशन की तैयारी कर रहे हैं, तो आप घर पे रहिए, और उससे पहले आप कॉलेज से जुड़े थे, यूनिवर्सिटी से जुड़े थे, चूँकि ये हाई लेवल का सब्जेक्ट है, तो आप अपने टीचर से बेसिक चीज़ें ज़रूर करिए, थोड़ा समय निकालिए और जा कर के कोई भी कन्फ्यूज़न हो आप वहाँ दूर करिए. Globular or botryoidal. When the mineral's surface is in the forms of rounded, bulb-like, overlapping globules and projections. Example: hematites. Rain forms. It is similar to globular, but the shape of the bulbs or projections resembles to human kidney. Example, hematite. Rain forms hematite. Mammillary form. Mammillary, it is similar to a globular, but the projections are conspicuous in size, overlapping in arrangement and rounded in shape. Example, malachite. Thank you.